Welcome friends, myself Rutu Patel, lecturer in chemistry at Parul Institute of Engineering and Technology welcomes you all to the active learning video session on the chemistry. Now, as you all know that in the last session we have discussed something related to the chemical bondings. Now today we will continue all the topics related to bonding and further in the syllabus related to the chapter number 1, that is your atomic structure. We'll see today, that is the types of bond that was earlier discussed was related to the ionic bond, covalent bond, metallic bond. Today we will be taking up also the hydrogen bond. Then second we will discuss the molecular arrangements in solid, liquid and gases. Then we will discuss the structure of the solids, that is FCC, BCC, HCP. Then we will discuss the catalyst and its characteristics, type of catalysis and catalyst. Okay, now coming to the bond, first of all let us start with the metallic bond. You all know that metals are having very few electrons in the outermost orbital, that is valence orbitals. Now these valence electrons are very loosely bound and hence they can be removed easily by applying little bit of energy. The remaining portion of that particular atom which is positively charged is known as your kernel. Now these kernels are packed basically into the regular fashion. Let us try to draw and understand how the kernels and electrons are arranged. You have a positive charge, in that you can put the electron like this. So you can see here the positive charges are basically your kernels and your negative charges are basically your electrons. So here you can see that your electrons are free to move from one kernel to another into the structure. Hence this model is termed as your electron C model. Electron C model, why it is known as electron C model? Because your electrons are free to travel from one kernel to another. Now we can imagine this arrangement as the metal crystal as arrangement of positive ions in a sea of mobile electrons. You can see here very clearly that these positive ions are arranged into the sea of these mobile electrons and hence it is known as your electron C model. Okay. Now we can take up what is metallic bond exactly. See, we have given the description that how this bond is basically formed. Now we can define it very clearly as metallic bond is basically formed by simultaneous attractive interaction of electron by two or more positive ions, that is kernels of the metal. Okay, once again I will repeat. Metallic bond is formed by simultaneous attraction of an electron by two or more positive ions of metal is called metallic bond. So it is very clear that your electrons are continuously interacting with your positive charge, that is your kernels. Okay, now the next is we have to see what happens to the strength of this metallic bond. Now in order to define the strength of metallic bond, there are two factors that basically affects the strength of this metallic bond, that is the number of valence electrons in the outermost orbital of the metal and the size of the atom also affects the strength of metallic bond. So here you can clearly state that the strength of metallic bond increases with number of electrons and second factor is it increases with decrease in the atomic size. Okay, so it is very clear that the strength of metallic bond is going to increase when number of valence electrons increases and when the size of atom decreases. We can see here the metallic bonding can explain following properties of the metal. What are the properties of the metal? That is A is your high conductivity. You know that metals are having high conduction, so that is the one property. Second is your malleability. Now what is malleability? The property of metal to draw into sheets is known as malleability. Then the third property is ductility. What is ductility? It is basically the property of metal to be drawn into your wires. Okay, so malleability is related to sheets, ductility is related to wires. Now the D is the toughness. Okay, metallic bonding can explain the toughness. That can be one of the important properties in case of deciding the metals for the industry. Now another is your electron C model, that is your kernel electron interaction, that will definitely help us to determine the below metal properties. That is your A is your metallic luster. You know that there are free electrons in the metal. Now what happens when you give energy to these electrons? Then what will happen? They will gain energy and they will undergo from ground level to the excited state. Okay, and then after from excited state it will come back to the ground state by emitting specific characteristic colors, and that will give the specific luster to the metal. Luster means basically shine. Then you are already aware regarding the B and C properties, that is electrical conductivity and thermal conductivity. You know, when you supply, what happens basically when you are trying to give the energy to the metal, then what will happen? Your electrons will gain energy and kinetic energy of the metal increases, and due to this, sometimes depending on the type of metal chosen, the conduction is going to increase. Now then you can think of something related to malleability. As I told that malleability is a property of metal to be drawn into sheets. Okay, that is the thing. You can see here there is the E property, that is ductility, that is property of the metal to be drawn into wire. Metals possess very high tensile strength. Now what is tensile strength, hardness? These are the important parameters that helps industries to choose the metals. Now we can see something that we have seen in the lectures earlier. Now we can easily relate the things, that is, you are already aware about ionic bond, covalent bond. Again I will give some idea about ionic bond. That is, ionic bond is basically formed by the transfer of the electrons. Okay, and covalent bond is formed by sharing of the electron pair. Now when we are comparing the two bondings, that is your ionic bonding and metallic bonding, each are having the particular characteristics. Let us try to have a look on that. The first point itself is a definition of the two bonds. That is, ionic bond is formed by transfer of electrons between two different atoms, and here you can see that metallic bond is formed by attractive interaction between kernels and mobile electrons in metal crystal. Okay, that is the one point of the difference. Now second point tells that your ionic compounds are basically brittle in nature. Okay, it means that it can break very easily, but metallic bond compounds possessing metallic bond are basically malleable in nature. Malleable means you can draw that metals into the sheets. Okay, this is the second point regarding both the bonds. Coming to the third point, that is your ionic bond. Ionic compound acts as a conductor in the fused state. It means whenever you are trying to dissolve your ionic compound into water, then what happens? That particular solution will act as a good conductor of electricity. and when metallic bond is there, then what will happen? Metal acts as a good conductor in a solid state. Okay, this thing is you all are supposed to remember. Again I will put a revision. What are the 3 points? That is, the first point itself is a definition that ionic bond is formed by transfer of electrons between two different atoms. Then you can write here, the metallic bond is formed by attractive interaction between kernels and mobile electrons in a metal crystal. Then you can see that ionic compounds are brittle in nature, and you can see that metals are basically malleable in nature. The third point, that is, ionic compound acts as a conductors in fused state, and metallic bond or metallic compounds are basically good conductors itself in the solid state. Okay, now the next thing that is related to, you can put here something about comparison of your covalent bond and metallic bond. Now don't get confused. See, earlier we have seen that we are trying to compare the ionic bonding and metallic bonding. Now what we are doing, we are comparing our covalent bond and metallic bond, right? The first point that you all are aware is basically the covalent bond is formed by sharing between two atoms. So what happens, there is a electron share. Okay, electron pair is shared basically between two atoms. And in case of metallic bond, you are already now aware that it is formed by interaction of kernels and mobile electrons in metal crystal. So we can easily define these two bonds. Now what is the next point of the difference? You can see here, that is, your covalent compounds are generally liquids and gases, but in case of metallic bond, you have the metals are usually solids, but there is one exception, that is mercury, which is found in the liquid state at the room temperature itself. Now the third point, that is, they are bad conductor of electricity. It means your covalent compounds are not able to conduct the electricity, but as you know, their metallic compounds are good conductor of the electricity. So once again we can revise the things. That is, you know that the first point that we have seen is related to covalent bond and metallic bond definitions. That is, you know that covalent bond is basically formed by the sharing of electrons between two atoms, and in case of metallic bond, it is formed by interaction of the kernels and mobile electrons in metal crystal. Okay, then you have seen it, that second point, that is, covalent compounds are generally liquids and gases, while you can see here that metallic compounds are usually solids, and their exception is your mercury. Then the third point that states that they are the bad conductor of electricity. Okay, and here the metallic conductors are the good conductor of electricity. Now you can see here, we will try to switch on to the one of the very important topic, that is hydrogen bonding. Okay, it is one of the important bond in the chemistry as well as in the biochemistry field. Now let us try to understand the definition, and we'll take up the examples related to your hydrogen bonding. Now see here, the electrostatic force of attraction between covalently bonded H atom and highly electronegative atoms like nitrogen, oxygen, fluorine present in same or different molecules results in hydrogen bond. Now we can understand this definition that we are having a electropositive atom, that is your hydrogen atom. Now what happens, due to electrostatic force, they will form a bond with your electronegative atoms. They are nitrogen, oxygen, fluorine, which may be present in the same molecule or in the different molecule. Now let us try to take the example in order to solve the case. Now look here, you can see very clearly there are basically two types of hydrogen bonding. That is, you can see here, intermolecular H bond. Okay, what does this means? Inter means between two molecules. Usually there arises a confusion between types of the H bond, so be very clear. The first case is intermolecular H bond, that is the between two molecules. Now here let us take the example of ammonia molecule. Okay, nitrogen is having atomic number 7, so configuration will be 2, 5. So we can see here clearly that it will have the 5 valence electrons. Out of that, 3 electrons are used up in forming the bonds with the 3 hydrogen atoms, and 2 electrons are remaining unpaired. Okay, so what happens? This electropositive atom, that is your hydrogen, okay, of one ammonia molecule is going to form the hydrogen bond with electronegative atom of another ammonia molecule. So what is the thing? Hydrogen of the ammonia molecule here is electropositive, so it will carry plus delta charge, and here nitrogen of another ammonia molecule is negative, so it will carry minus delta charge. Similarly, you can take another example for the water molecule that results into formation of your intermolecular H bond. Now look here, there is a oxygen. Okay, you are already aware that oxygen is having the atomic number of the 8. So what is the configuration? 2, 6. So already 4 electrons are there here, and 2 electrons are used up in forming the bond with the 2 hydrogens. Now you can see very clearly that this oxygen is carrying negative charge, so it is having minus delta here, and this hydrogen of the another water molecule is having positive charge, so it will carry plus delta over here. Okay, so there is a bonding, and always remember that hydrogen bond is denoted by the dotted lines. That is very important factor. Now this is the 2 examples for the case of the intermolecular H bond. Inter means between the molecules. Now let us try to take the another case of intramolecular H bonding. Now see, usually there is always a confusion between intramolecular H bond, but we'll try to clear up the things. The second case, that is basically intramolecular H bond, states that intra means within the molecule. Okay, so there are no different 2 molecules or 2